In this video, the great amplifier principle is used to make audio equipment, PAs, stereos, and recording studio stuff. To illustrate the great amplifier principle, here is a voltage divider which reduces the voltage to 1/10. 1 volt on the input yields 1/10 volt out. If this divider is placed around the negative input of an op-amp, the op-amp will have a gain of 10. The great amplifier principle is that whatever a network does by itself, in the negative feedback circuit, it's undone. A voltage divider which divides by 10 gives an amplifier with a gain of 10. Hook the divider to the amp and you might just as well have a wire. Here is a low-pass filter. In the negative feedback circuit, it becomes a high-pass filter. Here is a high-pass filter. In the negative feedback circuit, it becomes a low-pass filter. Now we can introduce the audio circuits used in stereos, guitar amps, recording studios, and so on. Here is a simple amp with 2 resistors in the feedback circuit. This will amplify just fine at low gain most of the time. The problem with it is that it amplifies everything. Voltage which doesn't vary carries no information, no signal. Direct current, or DC, is unvarying voltage and has to be blocked to prevent possible distortion. Other frequencies may be unwanted as well. Here are the steps taken to make the circuit better. Input and output capacitors block DC. A resistor to ground on the positive input keeps it referenced to ground. A low-pass filter in the feedback circuit gives unity gain for DC. Here, then, is the classic audio circuit. This classical preamplifier has a gain of 100 and tailored response. If you saw my video on the capacitor, you know the negative feedback network is a combination of a 100-to-1 voltage divider, a high-pass filter, and a low-pass filter. Here's the response of the network by itself. Here is the response of the amplifier. The amplifier is designed to amplify only audio signals, classically 20 to 20,000 Hertz. Often microphone preamps have a switch to attenuate frequencies below 70 Hertz or so. Here is a circuit to do that. The output of the preamplifier is fed to a power amp, or in the recording studio case, to a mixer. Configurations of the circuits between the preamp and power amp, or mixer, are outside the scope of this video, but are touched on in the capacitor video. There, tone controls are explored a little. The number of possible configurations for tone and processing is endless. Everyone seems to have a different idea. Here is the preamp with potentiometers on the output for fader and pan. Each end of the pan pot goes to a mixer circuit for one of the stereo channels. The mixer circuit has a unity gain buffer and a summer amplifier. The current through each input resistor on the summer amp sums with the others, summing the voltage at the output of the amp. To sum this up, here is a circuit for a small amp useful for PA or guitar purposes. Now you know the great amplifier principle and how to make audio stuff.